Question 3 is a relative motion question. You want to swim straight across a river that is 66 meters wide. So let's draw the river. You find you can do this if you swim at 18 degrees upstream at a constant velocity of 1.5 meters per second. So let's call this the velocity of the swimmer relative to the water. Here I've got the water relative to the ground going towards the left. So I'll call that V of the water relative to the ground. And we find that we can swim straight across means that the velocity of the swimmer relative to the ground is straight across. So we see that the velocity of the swimmer relative to the ground is equal to the velocity of the swimmer relative to the water plus the velocity of the water relative to the ground. We want to know what is the velocity of the water relative to the ground. It says at what speed does the river flow. We have that the velocity of the swimmer is given 1.5 meters per second, and theta there is equal to 18 degrees. So we also know that the velocity of the swimmer relative to the ground is directly up. So let's define some axes. We'll say x, well actually wrong. I think I'm going to do is make the x-axis go towards the left, since I've set it up that way, and the y-axis to be towards up. So the x component of the swimmer relative to the ground is 0. That means that the swimmer's swimming straight up. So let's look at x components of this equation. We will say that the swimmer relative to the ground in the x direction, which is equal to 0, is equal to the velocity of the swimmer relative to the water in the x direction plus the velocity of the water relative to the ground in the x direction. Okay. Which is just the velocity of the water relative to the ground, which is what we want to find. So, solving this out, we say that the velocity of the water relative to the ground is equal to, the absolute value of that is equal to the velocity of the swimmer relative to the water in the x direction. If we look at a little triangle which shows velocity of the swimmer relative to the water in the x direction and the velocity of the swimmer relative to the water, and shows this angle theta, we see that sine of theta is the opposite over the hypotenuse VSWX divided by VSW. So we see the VSWX is equal to VSW times sine of theta. This equals 1.5 meters per second times sine of 18 degrees. And if we plug into a calculator, we will see that that equals, let's clear this out, 18 degrees, click on sine, multiply that times 1.5 equals 0.46. So going back to this, see that the answer is 0.46 meters per second. And that is answer B.